Good morning, hackers. I am glad you're here. Woo! All I can say is thank you for playing Hackers Challenge. You guys played hard all night long, all week long, and I've been there, so I know how tired you are right now and just want this day to be over so you can go to bed. But I'm not going to tell you what you really want to hear, and that's who's at the top of the scoreboard. That's for next hour. So come next hour for the closing ceremonies if you want to see that. But right now, we are going to walk you through some of the stats of Hackers Challenge and answer your questions about challenges on how do you solve this, what did you like, what did you not like, and help you understand how we think a little bit more. So maybe you can win next year. Thank you very much to Santiago, to Rigel, to Squatch, to Anachronist, that were my staff and volunteers that were at the Hackers Challenge booth. I'm sure you interacted with them at least once this year. I've been saying for several years that I was going to retire from Hackers Challenge and be done. Enough that I would put a date on a coin that said that was the end for me. And then I had some staff that stepped in and said, hey, no, we can make this happen. And they saved me. I love Hackers Challenge, and I love doing it for you guys, and they've made it possible. So I will be back next year because of their awesomeness. So thank you. So Hackers Challenge, it's been quite the game. Most solved challenge was when I drove you all to AppSec to get started. Tons of you solved that challenge with most solves. It was very basic, very beginner, but it got you started. Not only was that a great beginner challenge, but there were several other puzzles across the board that hundreds of people solved. That I feel like we got a good beginner level there to get people started in playing the game. Both first and second days, and then moving on to our third day with Hacker Jeopardy. Hopefully you have some fun with that. We enjoyed it. Least solves. Thanks to our friend Professor Plum, we brought to you, Is This For Real? Awesome. It was an awesome puzzle. It was not as mean as some of my previous years or Professor Plum's previous contributions to this with anti-reverse engineering, but it was C++, and you had to reverse engineer it. It's a little bit templating and some of the structs and some of the grossness of C++ does not make reverse engineering fun. So we minimize the number of solves on that, but I'm impressed that every puzzle on the board got solved, even this one. Person with the most solves. We had a good old tie there with Nope, Sled, and Lego Clones. They both solved an equal number of puzzles. Now, they were not the same number of puzzles. Or not the same puzzles. Same number, but not the same puzzles. Total people who solved the challenge. We had awesome participation this year. Our numbers of people that actually played went up significantly. We had 250 players that solved a challenge. And then we more than doubled the number of players that solved more than 10 puzzles. So we had 98 people, close to 100 of you out there, that played the game enough to solve 10 puzzles, which is awesome. I am loving to see that number of deep involvement go up. So thank you. Most incorrect attempts was Hacker Jeopardy, Hacker Tools 400. How do you open, so here you go. I want you to shout it out in a second, but if you were to open a door handle that was locked without tools or without picking it, how would you do it?
Sledgehammer.
The most common answer was under the door tool. How many of you think that should have been the answer? Okay, there's a fair of you. Now, how many of you have been coming to SAINTCON for more than 3 years? There's a lot of you. Okay, so what is the real answer? Film strip. A film strip. So our good friend PopeSec introduced to SAINTCON and into the InfoSec world the concept of using film strip to go over the door and catch an ADA handle and open this locked door. I've got a link right here. Let me show you the video. This was popularized by him, featured on Lockpick Lawyer, and shared by DeviantAlum. So here's the myth of how that works. If you would have gone down to the Lockpick Village or to the vault and asked them, hey, how would you open a door without lockpicking it, this would have been what their answer for you. So this challenge had the most incorrect guesses.
So what do we do if we want to harden our door again?
Okay, and then per person. So we had one user that had 654 incorrect solves and attempts on the puzzle, not on the board in general. The majority of those were on a single puzzle, which was the Strong Crypto Challenge. So I don't know what they were doing. I'm not sure if it was just every single string they could find or every attempt, but they didn't know when they had the flag, which should have been obvious once you had the flag, and they tried several hundred, almost 400 different answers. Total submissions. So we had close to 12,000 correct submissions. Close to 12,000 total submissions, with 30% of them being correct and around 70% being incorrect throughout the game. It feels high for a number of incorrect guesses this year, but it's probably in line. Total challenges, we had 75 challenges on the board this year, which is about average for what we normally do, including the Hacker Jeopardy category. And then total registered users, we had 372 users, which is a good increase from previous years. I think we're up about 100 users total, which makes sense with the conference growing. We added about 300 players, 300 people to the conference, and about 100 of them ended up being players. So I like that, 1 in 3 of the conference. And then total, beyond just people that registered, we had a great number of players, 250 people that actually solved the puzzle. So that was actually a really good increase to see people not just registering, but actually solving something. So thank you for playing the game. That's what I have for stats and slides. Unless there's something else you want to know on the stats or slides. Anybody? Okay. So what do you want to hear about? What puzzles do you want to know the solves for? What unique solves do you want to share about how you accomplished it?
Tell us about the GitHub.
Okay. You're talking about the super secret cool project.
That's the one.
Okay. Let me pull up that challenge. What was the URL for that? SSH deployer? Oh, I'll pull up the game board. I'm sorry if I make you dizzy with my traveling around the board, but that's how I see. Okay, this was in which category? It was the Hack Me, right? Hack Me Super Secret Cool Project. So the hint you receive is I built this service to automatically deploy my application to all servers that want to run it. All I have to do is provide an SSH username, a host, and I will connect out and give you a copy of the app. Please accept my public key. On this page that you click to, you see a general page that all you can do is put in a username, a host name, and a port, and click the button to connect. On this page, I provide you an SSH key, my public key, for you to install as a user on your server. And then I tell you what I'm going to do with that key. I'm going to copy to myself. I'm going to git clone at a depth of 1 repository, and then I'm going to SCP or make a secure copy over SFTP to your server, that repository. I bet most of you got that. You were able to spin up a VM or a server or rent a VPS on the cloud or use a really cool solution. I heard of this one was someone used ngrok, which is a remote forwarding service. So you can be behind a NAT. They'll give you a public IP to forward a port into your private anywhere you are. So if you don't know this tool ngrok, you should check that one out. And so you have to have it somewhere that I can SCP to, and you add my public key to your user. Once you've done this, and you watch and click the button, I will have actually copied a JIT repository to your computer. And in that JIT repository, you'll dig around and you'll see in the JIT ignore file that there's a .flag that's been ignored, and the public and private keys for my credentials here have been ignored. If you look deeper into that repository, spend a lot of time digging into it, you'll see, oh, there's the actual URL for that repository on GitHub. And then you'll spend lots of time rabbit holing with, hey, where's all the rest of these files that were ignored? Because the last commit was deleted the flag. Oops, I committed a secret, I'm removing it. And so then you realize you have to come back to this page and look at this. It says, oh, it says a JIT depth of 1, which means that I only gave you the top head, the top level of that JIT repository. All of the history has been removed. It is not in those objects. If you're digging through those, you're not going to find them. And so many of you came back to me and said, hey, what am I missing? What am I supposed to be doing? And what was the answer? What did I tell you? Go back to the home page and do what?
Understand everything.
If you don't understand something on that page that you see here, ask the question, why would he do that? That's how I like to approach things when I build these puzzles, is there almost everything in them have some sort of meaning. And so right here, in this URL, we have a SCP-P to specify which port you're going to connect to. -R to recursively copy everything in those directories. -C, capital C, means it's going to compress the archive, compress it, so it takes less bandwidth. And really, I just put it so there was another flag you had to look up. I didn't need to compress it. And then -A. What does -A do? Do any of you know? Or know now? Forwards the agent. So in SSH, you have an agent that stores your private key on your local workstation. And that way you don't have to type in your private key password every time you SSH to something. Well, you can forward a socket that agent opens to the remote host so that it can authenticate to other hosts with your agent that's on your own workstation. And so when I SCP to you, I'm forwarding my agent to your host. That means that you can act just like you were me. You can connect to anything I can connect to if you use that agent. This agent ends up in your /temp directory as a socket. And so all you have to do is use, while that socket is open in your /temp directory, you just have to SSH to that JIT repo and pull down that copy of that JIT repository because you have my key, you have my agent that you can use. Does that make sense? Did you get it?
Get it now.
I had a lot of fun building this puzzle. If you didn't get the flag, I want each of you to go to this website, whoami.flip.io. And I want you to check out this tool and SSH to whoami.flip.io. And I'm just going to show you what this does. So this URL was the flag that you found. So when I connect to the server, it says right here at the top, hello, zevlag. How did this random URL, how did this random page know who I was? Well, your public key is public, and GitHub publicizes everybody's username and their public keys. And so because of that public key, they're able to reverse this. Well, this tool also checks for SSH agent forwarding and a whole bunch of other nasty SSH things that you might not be aware of. So if you're interested, check out whoami.flippo.io and learn a little bit more about public keys and SSH agent forwarding. Okay, next.
Crypto with the weird word concealment. I think it's the name
Concealment. Okay. This is a classic cryptography. Just extract the plain text. Here's the ciphertext. So this is something that you might call a rail fence, or a variation of a rail fence type cipher. Essentially, what you'd notice here, an easy way to identify this, is right here, we have, you'll have noticed that there's a lot of times that we'll say flag equals, or we'll put brackets around our flags. And so between this character here and this right here, there's 5 characters. And so essentially what happens with this classic cryptography here is every 5 characters you pull out, and that's your flag. One way to identify it is just a little bit of brute force some of the classic ciphers. Did you have an intended solution for this, Santi? Yep. Classic cryptography is fun. It's weak, and it's identifying patterns that are meaningful. Only 8 solves, yeah. Yeah, we can pull Professor Plums. Hey, Plum, are you in here? He said he was going to be. He probably ended up downstairs. Who solved Plums and wants to talk about their process for me? I'm not a RE expert. I did walk through it and did accomplish it, but I'm not the right person to talk through it. We have a couple in here that solved it. Are you willing to share? Okay. I'll show you the source, show you the nastiness of it. I won't walk you through the whole RE process. So the program simply reads a binary file, and the goal is to understand the format of this file. Because there's a moderate use of standard and C++ class inheritance, it makes it nasty for reverse engineering. The file reader class parses a binary file, looks for a magic header, and tag structure. The extended reader extends the file reader to support additional tag types. One of those tag types will read out the flag. Another will decrypt it. However, because it uses class inheritance and standard disassembly types, quickly gets difficult, despite how simple the program is. And I'll just show you how simple this source is. We've got a really straightforward main. Let me blow this up, I'm sorry. Okay. Really straightforward main with a few class inheritances. A file reader. There's nothing fancy here. We're not doing any crazy stuff. And it's just really straightforward. You have to read the binary file. But because of it, there's so much inheritance, it's a pain. If you want to ask Plum about it, I'm sure he'd love to walk you through it. But I'm not the expert to do that today. We can publish this one, yeah. I'd be glad to share it. Yes. You're going to sigh when I show you the answer to this one. Butter Brute. The name of this game is using the word list. You can write something yourself, figure out how to load it into a hashcat. Good luck. So we give you the word list. It's not a long word list. We give you a Buttercup password manager file, and all you have to do is log in. So you can spend lots of time trying to figure out how to do it in hashcat. I couldn't. That was a little bit of a misdirection there, because it would be cool if you could have actually done it. There's lots of ways that you could accomplish this. You could write an orchestrator to just brute force it with the standard CLI system, or you could simply pull up your web browser and go to DuckDuckGo and search for Butter Brute. And right here at the top of Butter Brute, top of DuckDuckGo, Buttercup password vault cracking tool. Did you say there was a mic I could pass down around? Oh. You want to share with us about your experience? No? Okay.
All I say is I'm a failure at Google, apparently. It took longer than it should have.
So, my opinion is Google has failed us all. Switch to a better browser, switch to a better search engine. But Google has failed us all in many ways. I have that problem every day. Oh, Hextol 3, is that what I heard? How many had fun with your daily Hextol puzzle? Woo! Yeah! Santi, thank you so much. Now, we all have enjoyed Wordle, and so we brought you a new game called Hextol, where basically you have to play Wordle, but with a hex string, and you have a limited number of solves, a limited number of character space, so you think it'd be pretty solvable. And amazingly, I don't know how you all did it, but you all played Hextol the hard way every day. Santi, you want to come and tell us about the easy way to play Hextol?
Yeah, sure.
Okay. Yeah, come on. Come on, use the mic.
So, the easy way to play Hextol is actually knowing... Sorry. Oh, hello? So the easiest way to play Hextol is actually knowing the string before or the moment you create your user. because that was what we used to generate the string. Now, on top of the user, there is a dictionary that would change every day. So knowing that dictionary keyword and your username was the way to do it. And that's what we meant for Wednesday 3. So we push you to figure out that seed and your username, so you could solve that one.
How do you get that dictionary?
That was one of the hints. That's Rockio. Rockio is a very
How many is that linked to Queen?
Yeah.
What was the algorithm used to generate the?
MD5,
It was MD5 hash.
a concatenation of your username, or one key in the dictionary, and an MD5 of that. So it was like the crypto like hashing and everything, 20 seconds tops. Yeah. Now, I do want to mention something. Somebody actually figured out a way to generate multiple users and see the variations in the hexel and try to kind of like differential analysis on that. So that was impressive.
We love seeing the things you guys come up with. Print this. Well, come on, tell us about it. That's what I was showing you had making that. Yeah, I'll see if I can pull that up.
There we are.
Trying to,
Don't know if we have the tools on here to show.
I might have them. Just a second. Let me see if I,
Okay.
what category do we print this in? Reveal and Finder.
Yeah, perfect. All right, if I drive.
Yes, please do.
Okay. So one of the things that I wanted to do on this was actually make it so nobody would print it. So I put it on Super Lollipop.
Take 4 days to prep?
I think this one's like almost 2 days worth. Sorry, his view is not the way that I'm normally seeing it on my computer.
I don't actually use Prusa Slicer. I don't have a Prusa printer, so, but I have used it before.
Legend, no.
So one of the interesting things about print this is G-code is printer dependent usually, and so we discourage you from printing it. It's not STL that you can easily tear about into multiple objects.
All right, let's see if I can.
2 fingers to, I think, drag.
I'm trying to actually rotate. Oh, there we go. Sorry, I'm not a Mac guy, so this is hard for me to. I don't know what I'm doing.
Yeah.
Yeah, so drag me up into the to where we can actually see the like looking at it vertically, like straight on.
Like that? Is that the
Yeah,
you?
this is top down. So what I essentially
You want it
inside
bottom
of-
down, bottom up?
Yeah, where you had that view with where you're looking at the pole. But now go straight up. Don't rotate it, just go drag it straight up.
Oh. Right, here's your,
So what that is, essentially, let me explain what's going on here. Go ahead and do the top
Yeah.
view. Just go do the top view and do that. Okay, so what you're gonna see here is I have a bunch of infill.
will you use this, please?
Oh, sorry.
Just pull off the bottom. There you go.
So there's a bunch of infill, but you're gonna notice that the key is actually in there, but I've rotated it in such a manner that slicing it this way, I guess in theory you could do it if you take a picture every time and then rotate. But essentially the key is in there, the flag is in there in a vertical way. With Prusa, I know that you can go through and look at it and take out different things. So like you remove all the infill, remove different things, and it still leaves the outer shell and the key inside, and then you wind up just zooming your camera into it and you can read it. And there are a couple of other tools that I found online. It's because, at least with the G code that I left, there is tags saying what each part of the extrusion is. So part of it's labeled infill, part of it's labeled this, part of it's labeled that. And that way you can actually get rid of everything but what you need. And like I said, the last part is you just wind in looking out past the outer wall, and then you can read the key in there and the flags. How many licks does it take to get to the center of an STL?
I had fun solving this one. I loaded it through various things before I found Prusa that worked for me. But thank you so much for your contribution. Another one? Anybody? So, what was your first guess?
I was like speech recognition, voice to text.
Okay, so hacker tools to type really, really fast. His suggestion was speech recognition or voice to text. So the answer here you're looking for was a rubber ducky. A well-known Hack5 tool that does keyboard injection. It's a USB, it looks like a USB drive, often embedded into like the OMG cables, but rubber ducky was the answer you're looking for. As a hacker tool to type really, really fast.
How about Python, compiled Python with no main and add magic numbers?
Wasn't that a fun double Jeopardy for the last night? You want to tell us about it, Rachel?
It's the beginning of the dissimilar app. So I'm Rigel. I wrote it was a pickup line. Yep. All right. So pickup line is I took a Python a function that did AES encryption, and then mangled the key using a random permutation. But I told you all that if you read the disassembly. So Python has a disassembler. So when Python fires up, it compiles itself to a bytecode and then executes that bytecode. What I gave you is the disassembled bytecode. So it's like a really bad and slow processor, like the JVM. So what you had to do, so right up here at the top, and if you looked at strong crypto, you'll see that I cut and pasted. Once you start figuring this out,
Stronger crypto, yeah.
Oh, stronger crypto. You can see I cut and pasted the imports. So this is the equivalent of from cipher algorithm modes. So I'm pulling in the modes from cryptography. Pull in algorithms and modes. This is the encrypted key. Let's see. I call random.seed. Random.bytes to get 48 bytes worth of information. This is me mixing up the random bytes that you were just given, and then I do some XORs, some pluses, some minuses, some multiplications. Probably the most annoying thing, let's see, page down. And something I learned yesterday is that when Python compiles list comprehensions, it turns them into a new function, which is kind of hard to read. Sorry. But well, not that sorry. I saw somebody got caught up on this 22, thinking that was the length of a string. No, it's jumped to line instruction 22. But you can type this bytecode, and you could actually reproduce my source, except for getting the correct spacing. Everything you need is there to reproduce my source. And Python has good documentation on its disassembler. And the redacted was just because it gave my real name and where it was on my file system, so I just took that out.
So we did temper it. We weren't trying to be jerks. We know you're going to stay up all night working on it. Hopefully you had some fun.
Yeah, had I wanted to have been evil, I would have crafted my own opcodes. I just took, quick fact I learned 2 days ago is that Python has an optimizer, which sucks.
I do guarantee that next year we will have a little bit beefier RE category. Like this one had some fun stuff in it. You're going to see some unique things next year. So if you want to learn about building some state machines or some different platforms, you'll have some fun next year. You want to know about the Hackers Challenge store?
Yeah, I did find this, where there was a flaw. I was able to do all the stores the same way. I want to know how many people figured that out.
Yeah, so Hackers Challenge store for like the first 6 puzzles, was that the first 6 puzzles in it? Approximately that. There was a flaw that got identified that was not meant to be left there. We fixed it before we released the later ones, but it was in design mode we fixed it, and just didn't make that chance to fix it in the earlier ones.
I used the same thing on all of them. Awesome. So maybe you didn't find out.
If you found a flaw that works for all of them, we'd love to hear about it.
Yeah. Add 0.
Yeah, but I did set quantity to 0.
Yeah, I had one random item for $1, and then make the API call and said add 1 hacker challenge, but no, add 0 flags.
So I'd encourage you to go back. Oh yeah, so he indicated that he had added 1 Hackers Challenge item and then added 0 flags to the store to solve all of them. So we missed that check. There's multiple ways to approach it. But yeah, that was what that was. So yeah, I'd encourage you to go back and find the other flaws for each of those days beyond the back door. My wife's calling me. Give me 2 seconds. No, I'm not on stage. What do you need? She did. Are you done in your talk? No, I'm not done. So, okay. So Hacker Challenge Store was lots of fun. Thank you, Santi, for building an awesome range of puzzles for us there. Hackers Jeopardy. Did you like it? Okay. Especially the emojis. Okay. We took a break from the Hackers Jeopardy last year, but we heard feedback that it was missed, so it returned.
Can you explain the firewall once?
So we made multiple iterations of firewall, trying to make it make sense. I'll explain our final iteration and one of our other options. Where am I looking? Oh, I need to unlock this. I'm just going to go, yeah, let me unlock it really quick. Now, how many of you failed Hackers Jeopardy because you did not know how to answer, even though you knew the clue?
It took me asking someone else. I didn't read the instructions.
Because I did not read the instructions, I had to ask somebody else how to do it.
I did that.
Oh, Rigel did that. Santi did it. So
Punctuation that got me.
he was missing punctuation. I will tell you that we use a very liberal regex, and we try to be very friendly with our expected answers. All it needed was a W at the front and a question mark at the end, and then the right word somewhere in the middle. So whether it was who, whether it was what, whether it was we were trying, we don't want to be picky about the answer, except that you know the answer and have the right format for Hackers Jeopardy. So
would you have accepted John Draper instead of Captain Crunch?
no, we wouldn't have. Yes, so we did. Yes, so on these we also accepted. For some of these, we accepted multiple valid answers. So John Craven instead of Captain Crunch.
2 seconds after I typed it in and submitted, I wondered about that.
Yes, so for the famous hackers, we accepted both real names and handles.
Ironically, I got John Draper because I put the question mark after Captain Crunch without it.
So he got John Draper before he got Captain Crunch because he missed the question mark. Okay, so you wanted to see emoji movies. Last one. Okay, so the answer to this one is firewall. So the fire at first is very obvious. Now, this emoji of a police officer, we are intended to be the law. And, and the direction was read the law backwards. So, firewall. We tried like a carrot or a carrot 2 as other ways to try and explain it, but this is what we came down to be the clearest way to express firewall. I hope you got it from Fire and just Googling a list, and that's what Rigel did.
I asked ChatGPT for movies to start with Fire.
He asked ChatGPT for hacker movies to start with Fire. That was a perfect approach. Which, emoji 400? Pirates of Silicon Valley. Pirates in the desert. Pirates on the... Yeah. Yep. I loved building Hackers Challenge for you this year. I loved working with the team. I loved watching you learn. Your aha moments were amazing for me. Your unique solves and your approaches to it inspire me. So thank you for playing. I've got about 10 minutes to still if you want to have any more questions. Otherwise, we'll wrap it up.
Rigel, will talk about the recursive or the file types.
Oh, recursive. Okay, I can talk about the mini badge. Yeah. So he wants to know about the mini badge. I also want to talk about was it stronger crypto or strong crypto?
Which one are you thinking of?
The one that rabbit holed me.
Oh, yeah.
That's strong crypto. So I spent, he sent me this really cool challenge, like, okay, I love this. I got lost in it for 2 hours before I realized, oh, I know what's not going on here.
Can you bring up the Python code that I gave you for that one? And then I'll remind me to talk about mini badge. So this is strong crypto, and it's actually inspired by a different capture the flag put together by Wayne State University. But I thought I could do it better than they could, so I did. So in this challenge, you're given a Python file, which encrypts a piece of text. Oh, it generates an RSA key. Well, it generates a large number. Uses that to generate a
Strong.py,
key
right?
pair. Yep.
Okay.
That's it. So it generates a RSA key pair, and it tells you some information about the plain text.
There you go.
You get some information about the plain text. The plain text is going to be all lowercase, or it's going to be a space. Okay, one thing I learned Tuesday is that Python's is lower. Okay, I'm a C programmer by heart. I'm not a Python programmer. I fake it. Is lower on Python ignores anything that's not a letter. Who thought that was a good idea? So this is supposed to tell you that the plain text only contains letters and a space. So your entire alphabet is 27 characters long. Okay, so I generate a private key. I then take the pieces of the public key and do, for each letter in the plain text, I do the modular exponentiation. And folks, modular exponentiation is still hard. We don't have enough qubits to factor large prime numbers yet to make RSA tractable. If we did, if I had figured out how to break RSA, I wouldn't be standing here.
No, you wouldn't.
I'd be collecting my Nobel somewhere, perhaps.
So I'm sure a lot of you spend a lot of time digging through RSA and trying to find the flaw in his RSA mechanism, right?
Yeah. Okay, so a practical problem of RSA is if you take a number and raise it to a power, and then you do it that same number and you raise it to a power, you get the same number. So when a practical limitation of RSA is you have to use random padding. There's no padding.
There's no padding.
So when I take the letter A and modular exponentiate it with the pieces of the random key, you end up with a really large number. But if you go through the ciphertext, can you bring up the ciphertext? Mm-hmm. Oh, you've got it right there on the other tab.
Yep.
You'll notice there are repeats. It ends up being a substitution cipher. So then you just need to do frequency analysis on it. Quip is my go-to for such things. You found a different one. You just need to do ladder frequency analysis. Take the big numbers and call the first one you find A, find the next one B, then take it to a substitution software and done. A few seconds later, you've got the answer. It doesn't work well with Quip because you also have to identify the space.
Yeah, so this is the tool I liked.
Yeah.
But
All right, so that was strong crypto. The original implementation for what Wayne State University used was they did it with AES, but they used ECB mode, so one key to encrypt each plain text byte. And the only people who use ECB mode are folks that are making mistakes. So that just led me right down the path. I'm like, I can do this better. We'll do it with RSA. Now the mini badge, there were 2 challenges on the mini badge.
oh yeah, that's the altnet.
And the first challenge was you just needed to run strings on the you had to extract the image from the EEPROM that's on the board using whatever tools you like.
On I2C bus, our Hackers Challenge mini badge did the same thing 2 years ago.
Yep. And the first one you can get just with strings, or actually I just brought it up in VI. VI is my tool for everything forensic because it opens binary files. And the other one is I went through all of the file names or file types that Python supports natively and said, okay, let's make a rushing nesting doll. So it's a JSON with a base 64 with a tar with a gzip with an AR with an LZMA with a zip that was then base 64 encoded.
And you can do all of that in CyberChef as well.
Somebody did. But the cheat mode that I learned last night is binwalk -M -lowercase e will recursively do the whole thing.
Really?
I learned it last night. Yep.
So the first challenge was a hardware challenge. Can you read the I2C bus and get the EEPROM? If you could, you got the first easy flag. For any of you that tried it and missed that first easy flag the first time, I did have to go back and add that other puzzle because I forgot to put the easy flag there. I'm sorry.
And I did have one person came up, he had gotten, okay, so it's base 64, and then you undo the base 64, you've got a zip. Zip files start with which 2 letters?
PK.
PK. He's like, I don't know what this file is. Okay, go find a file format that starts with PK. And then I said, do you know about the file command? He was running a Linux VM. No, what's that? He got an aha moment working on this challenge, and he ended up solving it too.
And so if you got to the end of the string, after the easy flag, and you got all this random base 64 and hex, and there was a little hint for you at the end of it. Who enjoyed that? What was the hint at the end of the string? Persistence.
Persistent, aren't we? Yeah.
So. Thanks for the help with that one. Okay, thank you.